Hello friends. So in this lecture we are going to discuss the questions of the mid-semester examination. The first question says that four suppliers can each produce a maximum of 100 megawatts. Each supplier has constant marginal cost up to this limit. A table is given where suppliers A, B, C and D with marginal costs 60, 40, 30 and 50 and the corresponding megawatt production 100 megawatts for all suppliers. The table is given. Then if the demand curve is given as P equals minus 0.25 Q plus $100 per megawatt hour, the first sub part of the question is determine the market clearing price and market clearing quantity. Then the second part is find the supplier benefit, demand benefit and maximum social welfare. And then the third part is if the demand curve is changed to P equals minus 0.1 Q plus $100 per megawatt hour, repeat 1.1 and 1.2. Here P is the price and Q is the quantity. We'll move on to the solution. Let me first open the solution. Okay. Now we'll first draw the supplier offer curve and the demand bid curve, the demand curve. So in the supplier offer curve, the lowest price is 30. So it starts with supplier C. So for 30, 100 megawatts. So 30 is the price, 100 megawatts is the starting quantity. Then beyond 100, the next 100 megawatts is for 40. For 40, the supplier is B. The margin for the marginal cost 40, the supplier is B. So this corresponds to B. And beyond 200, that is from 200 to 300, the next cost is 50, which is for the supplier D. Then the last one is A, which is $60 per megawatt hour, which is the last 100 megawatt 100 megawatt generation, that is up to 400. So this step like structure given here is the supplier offer curve. Now we are going to draw the demand curve. For drawing the demand curve, the expression is given. The expression says that it's a linear relation between P and Q. So P equals minus 0.25 Q plus 100. So if we start with quantity 0, then for Q equals 0, P equals 100, right? So for Q equals 0, the corresponding P is 100. Then suppose we are taking 400 here. The quantity is 400. Now if we are taking Q as 400, 400 into minus 0.25 is minus 100. Minus 100 plus 100 is 0. So price is 0. So for price 0, the quantity is 400. Now you join these 2 points to get the linear characteristic relating price and quantity for the demand curve. Now the point at which it intersects the supplier curve gives you the market clearing quantity and market clearing price. Corresponding to this point, the market clearing quantity is 200 and the market clearing price is 50. If you get any one of these, either the market clearing price or market clearing quantity, you can substitute this in this expression and you can find the other one. Okay, so that is with the first part of the question. So market clearing price is $50 per megawatt hour and market clearing quantity is 200 megawatts. Now you are asked to find the supplier surplus and the customer surplus in the second part of the question. To find the supplier surplus, this area should be found. The area which I am showing here, this one, because in this segment of the supplier curve, all the prices in this segment is less than the market clearing price, right? So that means the quoted price is less, that is the willingness is less, but what he actually gets for the sale is more. That means this is a supplier surplus. This area is the supplier surplus. Similarly, we can find the demand surplus or the customer surplus also. To find the customer surplus, you see this segment. In this segment, all these prices are high when compared to the market clearing price. That is their willingness, or the amount quoted by them for buying energy is more when compared to the actual price. So here in this segment, this is the customer surplus. So this is the area, customer surplus, this one, this triangle, this right triangle, the area of this right triangle gives the customer surplus. Now if you add this supplier surplus area plus the customer surplus area, you will get the maximum social welfare. Now to find this area, what you can do is this is a rectangle, this is another rectangle, so you add the areas of these two rectangles. To do that, this is 20, right, this is 100, so 20 into 100 plus this is 10, right, 10 into 100, 20 into 100 plus 10 into 100, that will give you 3000. Now to find the surplus to the customer, it is half into base into altitude. So the base here is 200, right, half into 200 into altitude is 50, 200 is 50, so half into 200 into 50, half into 200 into 50, which gives you 5000. If you add both, you will get the total social welfare, which is $8,000 per hour. Now you're going to change the expression. The third part of the question, if the demand curve is changed to P equals minus 0.1 Q plus $100 per megawatt hour, same way, similar to what we have done with the demand curve, the previous demand curve, same way we can draw the linear demand curve in the new case by substituting these 2 points, 400 as the quantity, you will get 60 as the price. If you substitute 400 for Q, you get P as 60. So from this point to this point, if you join, you will get the new demand curve. Now you repeat the same thing. Now the new customer surplus is this one, and the new supplier surplus is this one. So you need to take the whole area. Okay, so then what you get is so as a solution, what you get is demand surplus is 8000 and supplier surplus is 6000. So total welfare is 8000 plus 6000, which gives you 14000. MCQ is 400 and MCP is 60. That you will see from here at this point. This is 60. Okay, this is 60 and this is 400. Okay, this is 60 and this is 400. Yes, 60 and 400. Now we will move on to the second question in the next session.